Conditional operator is a ternary operator. We have already seen conditional operator. We have executed some programs also using ternary or conditional operator. It is, what is ternary operator? You know, ternary operator is a operator which will be taking 3 operands. Are you all listening? It will be taking 3 operands. So this operator is given as a separate classification. The conditional operator work as follows. We have studied that if the first operand, so you know, among the 3 operands, the first operand will be in the form of a Boolean expression. The first operand, which can be in the form of a Boolean expression, is evaluated first. Depending upon that evaluation, if you are getting, if the first operand evaluate to true or 1, then the second operand is evaluated. If the first operand is evaluated to false, then the third operand is evaluated. So only one of the last operands, first operand, anyway, it will be a Boolean expression and it will be evaluated. And one among the last 2, that is, if it is true, second operand is evaluated. If it is false, then the third operand is evaluated, right? Only one of the last 2 operands. What are the last 2 operands? Second operand or the third operand is evaluated in a conditional expression. I hope you remember this example. X equal to A greater than B, then question mark, then you have the value A colon B. So which is the first operand, which is the second operand, and which is the third operand in this given conditional or the ternary operator? Answer to me. Kiran Kumar, are you there? Kiran, he discontinued or what? I can't see him only. Every day I'm asking. Ananya? Ananya, are you there? Javid? Javid, are you there? Javid Pasha?
Yes, ma'am.
Tell me which is the first operand, which is the second operand, and which is the third operand in this conditional expression. All of you can answer in the chat box.
First operand relational.
Which is the, you tell me which is that operand, which is considered as an operand. Nirma has answered. Sachin has answered, which is the first one.
A greater than B.
A greater than B will be the first operand. Second operand will be A, right?
Yeah.
And the third operand will be B. So this conditional operator is a ternary operator. Is a ternary operator. That means it need 3 operands. The first operand is given in the form of a relational expression. If A is greater than B, then it is followed by a question mark to separate. So conditional operator is in the form of a question mark and colon, which will be separating the 3 operands. First operand is a relational expression, and the second one is the value of the variable A. Third is the value of the variable B. So when we solve this conditional expression, what will be the value? What will be the value? Sachin, what will be the value of X after solving this conditional expression? Sachin, if A is greater than B, substitute the value of A and B. Sachin, are you there?
Ma'am, A 10, B 15. A is not greater than 15.
Then?
So X
will be assigned what value? If so 16. This expression returned what now? False, right? It returned false.
Yes, ma'am.
If it is false, which part will be evaluated?
B will be evaluated.
B will be assigned to X. So what will be the value of B? B will be 15. So X will be assigned the value as 15. Alright, this will be the simplest example for conditional operator. X will be assigned the value of B. That means X will be given as 15. Okay, so that is very simple operator that we have studied before also. Now we are moving on to the next operator, which is very important. One question only which will be asked, but I think you might have studied in your CEO also, right? Bitwise operator. Now, till now we were doing all with without thinking in terms of binary or binary representation. We were thinking in the terms of decimal representation, right? Now, if you want to do some manipulation of the data, manipulation of the or some calculation at the bit level, if you want to do some calculation at the bit level, you will be using the bitwise operators. Is it clear? If you want to do the any calculation in the bit level, we will be making use of the bitwise operator. Bitwise operators cannot be applied for the float or the double numbers. If you have some decimal point, if you are having other than integers, if you cannot do bitwise operator. Bitwise operators can be done only on integers. Okay, C supports 5 bitwise operator. So we are going to study 5 bitwise operator, right? So the bitwise precedence, 5 and 6, one more is there, but okay, 5 is okay. Bitwise, I am having the slides for the 6, but still it is given in the textbook as 5 bitwise operator. Bitwise precedence is lower than, listen here, we had studied many other operators, right? Arithmetic operators, relational, logical, and after that also we have studied. So bitwise precedence is lower than arithmetic, relational, and logical operators. It is lower than these 3, arithmetic, relational, and logical. So when we construct the table of precedence, below logical operator, we have to give the bitwise operator. Bitwise operators are used for, so some uses where we are having the applications of bitwise operator in order to do the swapping at the bit level, testing the bits, and for shifting. So this mainly will be used for in computer networks and all, will be for a damage of the data received by packets and all. For that and all, we will be making use of the bitwise operators. So it will be at the minute level or the bit level. This users or the application you will not understand now, but for the time being, you can just list out the application of bitwise operator for the swapping, testing of the bits, whether on the when the packets are transferred between in the internet, when we are transferring the data, whether the received packet is having the same number of bits. For testing the bits and for shifting them to right or to left, we'll be making use of the bitwise operators. So bitwise operators are, some of the uses are for swapping, for testing of the bits, and for shifting the bits from to the right or to the left. So these are the important points which you have to write for the bitwise operator. Bitwise operators are used for manipulation means, or you can write as operations of data at bit level. Some operations, if you want to, that is we will be seeing in the next slides, all those bit level manipulations which we can do using the bitwise operator, and it's not applicable for decimal numbers. And it C supports 5 bitwise operator, and bitwise precedence is lower. So in the table, when we are having an expression with arithmetic, relational, logical, and bitwise, it will be solved at the end. So first we will be solving arithmetic, and then relational, and then logical. After that only we will be considering the bitwise operators. Got it? Then bitwise operators, some of the uses are for swapping, testing the bits, and for shifting the bits from right to left. So some of the bitwise operators are here: bitwise and, a single ampersand indicate it is a bitwise and. We have studied logical and, right? So here a single ampersand means bitwise and, bitwise or is a single dash, and bitwise exclusive or no is the symbol, and then that CART, I think, correct. And then shift left will be indicated by 2 less than symbol, and shift right is indicated by 2 greater than symbol together. So when we are using single ampersand, it becomes bitwise and. A single dash indicated it is a bitwise or, right? And bitwise exclusive or is indicated by the symbol, and shift left is indicated by 2 less than symbol, shift right is indicated by 2 greater than symbol. So when we are doing at the manipulations or operation at the bit level, we have to convert from the decimal to binary representation, right? So you have to, for these examples, we will be considering only the bitwise representation of the numbers. Are you all listening? So we will be making use of the bitwise, not the decimal. We will be making use of the bitwise representation. So instead of 15, you have to write it as 1111, right? You know how to convert. You might have studied in CO. And so the bitwise and is a binary operator. So we will be studying. So you know what is a binary operator. Binary operator, it will be taking 2 operands, right? For binary bitwise and operation, for the bitwise and operation, you will be making use of these 2 operands, and we will be finding the output. So output of the bitwise and, you know, if both the operands, so we will be considering at the bit level, bit by bit we will be taking. If both the operands are 0, when you give a bitwise and, you will be getting a 0. If one among the bit is 1, one among the bit is 0, you will be getting the bitwise and no, we will be getting it as 0, right? If one among the bit of the 2 operands, if it is 0, you will be getting the output bit as 0. If both the operands are 1, or both the bits of the 2 operands are 1, then you will be getting a output also 1, right? So this you have to keep it in mind. This I know this table you have studied also, right? If both are 0, 0, and if both are 1, it will be 1. If any of the bit is 0, then you will be getting 0. So this example you can understand and keep, and they will not be asking for a question like solving. I am not seeing, but may ask, you know, maybe like question paper pattern. If they change, they may give. And one problem, one C program, they used to ask in order to explain the concept of bitwise operators. So now we will consider the bitwise and operation between 12 and 25. Got it? So we know that in bitwise and operation, we are going to consider the binary form of 12 and 25. We are representing it as 25. You know, we can't represent it in 4 bits, so we are using it as 8 bit. So both we are giving it as 8 bit. So for 12, the corresponding binary representation is this, right? We have seen from the table, and you know how to convert from decimal to binary. And we are doing the and operation, bitwise and operation of 12 and 25. Got it? Both we have represented in the 8 bit, and we are going to perform in the bitwise and on the bitwise operator. So tell me what will be, all are ready, right? So Nevin, can you tell me what is the answer? Like here, one bit is 0, the other bit is 1. So what will be the output here? Nevin, are you there?
Yes, ma'am.
So what is 0, bitwise and 1? From the
For
table.
and up. For and, no, ma'am.
Yeah, and
0, ma'am.
0. Then the next bit is
Then
0 is
0, ma'am. 0, ma'am.
0. Then
0, ma'am. 1, ma'am.
1. Then
0, ma'am.
0. Then again
0, 0, 0.
are zeros, right? So corresponding to what is 1 0 0, 1 0 0 0 will be 8 in decimal, right? So you can convert from the binary. So this will be the bitwise and operation. So you should remember this table. Okay, so one example I'm just giving. I'll give you examples to example problems. So you can solve it later at the end, you know. So this table you should be writing, and you should remember. Okay, so bitwise and will be done like this. And now we will move on to the next step. In Bhagirasamy textbook, they have not given this much elaborate, but in the other textbook, you know, one more textbook, Srikand Skyward Publishers, and they have given little more, so I took it from there. Now we are going towards the bitwise or operator. All are listening. Bitwise operator. Bitwise or operator, you know, its representation is a single line. So the output of the bitwise or is 1 if at least one bit of the 2 operand is 1. So we are considering 2 operands are there, but bitwise when we are considering at least one bit. If it is 1, then the output also will be 1, right? So at least 1 is enough for AND. It should be like both should be 1, then only we will be getting 1. So here, so in case if both the bits are 0, we'll be getting a 0. So we'll solve one example with that. So you have to represent. Here I have taken the same two numbers, 12 and 25. So today strictly I'll be following attendance only with the notes, completed notes. Okay. And it should be sent immediately. Don't wait for the screenshot you will be saving and then copying from the screenshot. That I don't want. I know copied from my notes and what you are solving by yourself. I need only that much scribbling notes, running notes. I'll not wait for you to copy from the screenshots and then send me. Okay, so here again, I'm taking the same 12 and 25 and doing a OR operation. So what will be the answer? Here what we will be getting? Manikanda M. Manikanda, are you there? A section, Manikanda. Manikandan and Manikanda both are there, but no one is answering. Manikanda.
Yes, ma'am.
Tell me what will be 0 and 1.
1, ma'am.
1. Then next
0,
one.
ma'am.
Then
1, ma'am.
Okay. Then 1.
1. 1, ma'am. 0, 0, 0.
Okay. So corresponding to this, we will be getting the decimal form will be 29, right? Now we are moving on to the next one. So this example, I will be giving you one problem. I'll give you. Bitwise XOR is a binary operator. Again, this is also a exclusive OR, right? So for this, the symbol is actually this is exponential operator. We don't have in C. This is used for the XORing or exclusive OR of 2 bits of the 2 operands. So here when output of the, so only difference between XOR and OR, you know that when both bits are 1 or when both bits are 0, you'll be getting the output as 0, right? If both bits are 1 or both bits are 0, you'll be getting the output as 0. Got it? So that will be the only difference between. So here, when both bits are 1, we'll be getting an output as 1. Here, for both the, when both the bits are 1 or both bits are 0, you'll be getting an output as 0. So I'm taking the same number, 12 and 25. So here, when we are performing a bitwise exclusive OR, when we are performing a bitwise exclusive OR, so you have to follow the same thing. Who's that? Shalini, are you there? Shalini, can you answer this one? Tell me, Shalini, what will be the answer? Unmute and speak. So here, the only thing is you have to keep it in mind whenever we are having both zeros and both 1. Both zeros and both 1, that time alone we will be getting 0, or others will be here also, both zeros. That time you will be getting 0, all others will be 1, right? So when you are getting both zeros, it will be 0. Anyway, I'll be checking with the notes. So when we change this into all, should be typing the answers. I'll be checking. Nirma, what is that answer? Nirma B. Abhishek MP. Why you got 11101? Bitwise exclusive OR. Nirma and Abhishek MP, both of you have written wrong. Okay, so here the answer, now you have to see that whenever you have both the bits as 1 or both the bits as 0, you will be getting it as 0. Okay, so the corresponding, when we check in the, when we convert the binary to decimal, we will be getting it as 21. So this table you have to remember. Now the next topic is bitwise complement. This I didn't keep in the first slide. In Balagurusamy textbook, they have given only 5 bitwise operators, but in this textbook now they have given 6th one, that is bitwise complement. Listen here, bitwise complement, you might have studied also, no? Bitwise complement operation, also known as a ones complement, and wherever ones are there, it will be changed to 0, and zeros will be changed into 1. So bitwise complement of the integer. So this bitwise complement is a unary operator, right? It will be taking only one operand. Understood? Bitwise complement will be taking only one operand. So we are going to find the bitwise complement of the integer 12. So if we are the decimal integer, 12 we are converting into binary form 1101. You have to listen here. Listen here. When we are converting this into, this is very easy. When we are converting into bitwise complement manually, what will happen? Answers are coming. So wherever zeros are there, we'll convert into 1, right? 1 second. So instead of 0, 1, 0, 1, then 1 will be 0, 1 will be 0. Here it will be very easy. So we know that the corresponding to this, the decimal, this is a binary form. When we convert into decimal, you will be getting it as 243. It's clear, right? But when you execute this program, in your system or in your Turbo C, you may not get the same answer what you are expecting now. Can anyone tell me the answer? Why you are not getting the same answer? Can anyone tell me why you are not getting the same answer? This and all is correct. Manually, when we do, we will be changing 0 to 1, 0 to 1, 1 will be 0, 1 will be 0, like that. No, it is very easy to find the complement. The reason I'll tell you, we have studied in the different data types. When we studied different data types, I have taken one topic called unsigned integer and signed integer. Are you all listening? Unsigned integer and signed integer. Both will be taking for integer it will be 2 bytes. Both will be taking 2 bytes only, unsigned and signed integer. But only problem is in signed integer. Unsigned, if you are specifically giving, it will be taken it as a unsigned integer. But when we are just giving int, it will be taken, the first bit will be used for sign. I had taken in that class. The first bit will be used for indicating the positive and negative integer. If the first bit is 1, that means it is a negative integer. Are you all listening? For an signed integer, right? Listen here, this and all internal things also you should understand. You can't just mug up and write, go for higher studies. When we are going for the for an signed integer, when you are going for a signed, okay. So when we are going for a, this is not correct, I just took it from the previous. When you are going for a signed integer, what will happen? Among the 16 bits, the first bit, all are listening, right? The first bit will be made used for storing the sign of the number. Got it? The first bit. So among the 16 bits, the first bit will be used for indicating the sign. If it is 1, then it is a negative integer. Understood? So this is the problem. So now what will happen here after converting the to find the bitwise complement, you know that the first bit, which was 0, was converted into 1. Then what will happen now? It will be a negative. So if you have declared that variable as an integer, the first bit, it will be taken as a sign. So if it is 1, that indicates who is okay. So first bit, if it is 1, then it will be taken as minus. So this will be taken as a negative number. Now, understood? That is one case. And one more thing you have to understand. If your system is a 16-bit, now you have 64-bit system and all, right? Listen here. When you are using this is not required for your lessons and all, but you should understand the concepts. Why when you are running the program, why you are getting a different answer. That's why I'm explaining. most of your system will be 64-bit and all, right? So when till now in the example when I was showing it, I was just showing 8-bit, right? 8-bit. So the same 12 in decimal, 12 in the binary formula when we are giving, you will be knowing that 1100 will be indicating it as 12. But when we are representing in a 16-bit system or 8-bit or 16-bit, that day, the previous example, I was using only 8 bits. When you are using a 16-bit, what will happen? In 16-bit also, the remaining bit position will be 0. And when we are writing 12, it will be just 1100, right? Anyone is listening here?
Yes, ma'am.
Yes, ma'am.
Now when you convert, when we find the complement of this, what will happen? What will happen when you are doing the complement? So here, the previous slide I was giving only with the 8 bits, right? So what happened here? Instead of 0, I gave 1, 1, 1, 1, and wherever ones were there, I made it as 0, 0, and here it is 1, 1. So it became 243. Now what happened? Instead of that, if I'm representing in a 16-bit, 16-bit means we will just put zeros wherever it is empty. 16-bit 0 indicates nothing. So we will be just putting zeros. Unless it is preceded by 1, it is it's okay, right? When it is 1100, that indicates 12. The remaining portions, bit levels, you can make it as 0. When you are finding the complement of this number, what will happen now? What will happen? This and all is correct. Here, up to here, it will be okay. Here also it is okay. Then what will happen? After this also, all the remaining bit position where we merely gave zeros, now it will be converted into 1. Right? Understood, right? So when we are just finding the complement of a number, now what will happen? This number is not same as 243. When we convert this binary to a decimal, you will be getting 65,523. Understood? So this indicator, and one more thing is, if you have given signed or we have declared the variable as int, then means that the first bit will be taken as a signed bit, and then you will be getting a minus value, and it may not be this value also, minus some value, because when you are considering the assigned bit, you will be having number of bits for that will be again the same. If it is integer, you will be having only 2 bytes, but it will be distributed like for one byte it will be taken for the negative values, and 1 byte will be taken for the positive value. When we are making it as unsigned, what will happen? It will be taking only the positive value. So again, one thing only you have to understand, that the first bit, if it is 1, that means it will be taken as a negative number. Understood? So this just for your understanding, nothing is there for exam from this side, but when you are running the program, you should understand why we are getting a different answer. When you are this I explained for 16-bit. For your system 64-bit and all, you will be getting another answer. Understood? So the same 12 we have seen the complement in 8-bit. So you got 243. In 16-bit you got 65,523. Got it? So in 64-bit, if you are not considering as if you are considering as an unsigned, no, you will be getting. What is happening? You will be getting a different answer. Okay. So those who can understand, just like keep it in mind why we are getting a different answer, because we will be running that program. At the end, I am showing a C program. Okay. Now the next bitwise operator is for the right shift by 1. I am just showing you with the with a normal right shift. That only you need to understand. So the right shift operator is indicated by 2 greater than symbol, and is used to move the bits to the right. Move the bits to the right side by n. If you are indicating 1, then it will be bits will be shifted 1 position towards the right, and the empty position on the left will be filled with the 0. Are you getting? If we are giving 12 right shift 2, then it will be shifting the bit position by 2. Got it? And then the whatever empty locations are there on the left side, empty locations will be filled with the 0. So here, when we are again the same 12, the binary representation of 12 I have taken, and I am performing a right shift by 1 bit. What will happen if I am performing a right shift? So we will see here. So what will happen is we will be shifting. So what will happen is this 0 will be removed from here, and in this position, in this bit position, the next bit will be shifted to the right, 1 position, right? If I am giving 2, it will be removing 2 digits or the bits from the end, and the remaining or the bits which are coming up now, it will be shifted towards the right. So here I am shifting by 1 position. Right shift by 1 means I'll remove this 0, or to this location I'll be shifting the next bit, that is 0. Now to the position of this 0 we'll be shifting 1, then again 1, then here 0. This 0 will be shifted to the right by 1 bit position, here also 1. Now what happened here? 1, it is an 8-bit representation I am showing. So here 1 bit position is empty. So what will happen? We have to fill this empty location by 0. So we are assuming that we are like removing this 0 from here, and the bit location empty, whatever is there, we will be filling it. But the thing is, even if it is 1 also, after shifting, we will be filling it as with a 0. Are you all listening? Even if it is 1 over here, we will be filling the empty location over here with a 0. Are you listening? Here,
Yes,
after shifting, no, even if it is 1, we will be filling the empty location with a 0 only, not like 1 will be coming and sitting in the front. Okay. So this, if you convert this 110 into decimal, you will be getting it as 6. So 12 will be converted into 6 after right shift. So you can write the definition for right shift. So moving the bits to the right side by n. I am showing the example with the shifting. Right shift by 1. You can perform right shift by 2, 3. I'll give you examples to solve with this. I'll send you the questions. Now left shift by 1. So if you are performing the left shift is indicated by 2 less than symbols. Moves the bits to the left side by n positions. Leftmost n bits are lost. Leftmost bits are lost, and the empty location. So when you shift like this, what will happen? 1 bit will be empty. So that location is filled again with the zeros. So all this we are considering in case of unsigned integer. You know what is the meaning of 1 in the most significant bit. So we are considering only unsigned integer. Got it? So left shift by 1, we will be performing with the shifting the n bits from the left side. Okay, you will be moving, and then the empty location on the right side will be filled with the 0. So again we will see. Then we will be performing the left. I just kept in the beginning itself. So we will be moving the bits 1 location or 1 position towards the left. Okay, so the corresponding to 12, when we perform a left shift by 1, we will be getting 24. Hope it is clear. So the same thing I'll be asking to solve. I'll be sending the questions, so you should be knowing how you are doing. So we are just filling the empty location wherever we have with the zeros. Understood? It's very simple, and we are not making considering signed integer, only unsigned integer. So I have summarized all the bitwise logic, bitwise operators over here. Here the bitwise and, bitwise or, bitwise XOR, bitwise complement I didn't keep, and then the left shift and right shift. this is the program which you have to execute. I'll execute and show it. So this is a sure question for exam. They will be asking you to do the bitwise operators. Explain the bitwise operator using a C program. So you know, whenever you are using the bitwise operator, so here we are declaring, I have declared it as a signed only, signed integer. So it will be like a and B are signed. If you want to declare it as unsigned, you can give it as unsigned int A equal to 12 and B equal to 25. And then we are finding the bitwise operation and here for bitwise and there are two operands A and B. So we are performing the bitwise AND of 12 and 25. So in the first example we have seen, so we will be getting the output. The output will be printed in place of this %D. Now we are performing bitwise OR using the OR operator. And we are performing the bitwise XOR or exclusive OR between A and B. All these three are binary operators, right? After that, we are finding the complement. This only I told, you will not be getting the expected answer. Okay, depending upon the system, how many bits the system is using, the answer will be different. Even if I tried many things, even with unsigned integer, everything I tried. Then also you are getting different answer. So it's okay. You will be getting a minus value. That's okay. Because even if you convert into an unsigned integer also, you'll be getting a bigger, longer answer, like 14,000 something you will be getting. So we are finding the complement of A. Complement of A.